Hi class, let's take a look at example 2. In example 2 deals with technically a probability. They're asking us to find the probability that the height of a specific, in this case a male, is in between these two values. And we're told that the data is bell-shaped, but we're actually told that the values of mu and sigma are not 0 and 1. So therefore, this one is just normal. It's not standard normal. So all of these values that we have here, the 64 and the 8, are not going to be z-scores. They're going to be x values. So in this case, you could label that one as x1, and that would be your second x value. So they're not actually z-scores yet. And before we start finding probabilities, let me declare the events. In this case, you're going to let x equal 2, and this is technically male heights. Now, before we find any probabilities, if we're working on a problem like this, they may want us to change everything to z-scores. So what I'm going to do is I'm going to change all the x values to z-scores, and then find the probability that well, technically the random variable, or in this case a selection, is in between those two. So the main problem that they're asking is that the actual heights are in between 68 and 80. So I'm just going to write it as less than or equal to, in this case, 80, and greater than or equal to 64. Now, at this point, we're looking at data that is just normal, with mu is equal to 69, and then sigma is equal to 2.8. So what I'm going to do is I'm going to standardize the data set and change your x values to z-scores. So the first z-score, it's actually going to be x minus mu divided by sigma. And your x value is 64 minus 69. So 64 minus 69 divided by 2.8, it's going to be approximately, and let me double check, 64 minus 69 divided by 2.8, I'm getting negative 1.79. That's going to be your first z-score. Your second z-score, I'm just going to label it as Z2 is equal to x, technically 2 minus mu divided by sigma, or in this case 80 minus 69 divided by 2.8. So your second z-score, it's actually going to be, I'm getting 3.93. And I'm just rounding to 2 decimal places, because some of the problems on the software, they may ask you to round to 3 decimal places. Okay, so going back to the problem, this one actually now represents the probability that C is less than or equal to 3.93 and negative 1.79. This is the actual statement that we're actually solving. At this point, this is standard normal, with mu is equal to 0 and sigma is equal to 1. So that what we just did here is actually this portion here, where you technically have a distribution that is only bell-shaped with parameters a and b. To find any probability, you would technically standardize it, make everything into z-scores, and at that point, it's a distribution that is placed at the origin with zeros and ones. To find that probability, you can use technology or the tables. Most likely, they're going to want us to use technology. Let me run it. So in this case, we're going to end up with a normal CDF. And this is negative 1.79. The second value, our upper bound, is 3.93. Okay, so evaluating this one, I'm getting 0.8632. So the final value, or the probability that the height of this specific individual is in between those two, is just going to be 0.9632. So 0.9632. And in this case, we're basically standardizing the data set and making the problem, well, standard normal. Now, let me actually do the shortcut here. And let me explain this particular problem. So the problem is not asking for Z-scores or for us to standardize the data set. You can go directly from, and let me use this portion. So you can go directly from here to the answer by using the shortcut of the code. Now, if you're going to use this shortcut, let me just clear everything. You would basically look at the following. This will be normal CDF, and then you're going to be typing in the original parameters. So you're looking at 64 to the values of 80. Now, your calculator has the capacity to adjust it so that you don't have to standardize it. Mu is equal to 69 and sigma is equal to 2.8. Whoops, 2.8. And then run it here. It's going to be a little bit off, and this is because of the rounding of the Z-score. Notice that we're getting 0.9628, 0.963. So a little bit of rounding error. We only matched to 3, but that is because of, well, basically this portion here, the rounding of the Z-score. Now, on a typical problem like this, it may just ask you to use technology. It may ask you to do the table. So if you go directly to the shortcut, I would want to see the code somewhere on the paper. So you would have just said code, and this will be normal CDF, technically 64 to 80, and then 69, and then 2.8. So I do want to see the code if you go directly. Also, since you're doing the code for this particular one, or we did the code for that one, I do want to see the code, how you're obtaining that value. So on that one, the code would have been normal CDF, then negative 1.79 to 3.93, but you're using 0 to 1. So I do want to see the code. Most likely the tables, we're not going to use them. That's technically just in case we don't have the calculator. But expect that the software on some of these, they may want you to use a table. Okay, so that's it for this one. As you can see, a little bit of rounding, but not that bad. Let me actually show you how to do the shortcut of this particular problem, which is equivalent to what we did on problem E, using the inverse norm, and problem D from the first example. So technically this is what they're telling us. So let me create a sketch of the distribution. So you still have a mu is equal to 69 and sigma is equal to 2.8. X is equal to, well, technically heights, and let me just put the unit, so it's actually inches. Okay, so what they're saying is that they're basically no longer accepting the short is 3% and the tall is 4%. So this value here, it's going to represent 3% of the population of or 0.03. This value here, it's going to represent 4% or 0.04. Now, remember that the actual calculator for the inverse norm only works on area to the left. So your new requirements are going to be as follows. So let me just write them here. Now, to find the one at the 3%, you're simply going to do a second, and in this case, inverse norm. We want 0.03, but you have a specific mu and sigma. That's going to be 69. So mu would be 69, and then sigma, it's already given as 2.8. So the actual new requirement would be 63.73. So your x1 is equal to 63.73 inches. So 63.73 inches. And obviously you would write the code. Let me just show it again. And that's because for that specific first score, you have 3% of area to the left. Now, to find the second one is a little bit tricky, because to find this actual value, you have 96% of area to the left. So you're basically just going to run the same command, but you're gonna adjust the area to the left to not 0.03 but 96. Oh shoot, I did something. Okay, let me clear it. So 0.96, and then everything else is the same. So we're getting that the second one, so your x2 is equal to 73.9. So 73.9. So 73.9, and we're talking about inches. Those will be the new requirements. So this one will be 63.73. This one will be 73.9 inches, and technically inches. Okay, I do need the code. So if I were to give you one of these problems on the final or on the next exam, and you're doing it by paper, I want to see you write the code on the side. Same idea what we did here. I'll leave it like that, but we need the code. And once again, inverse norm only works for area to the left. So if you accidentally put 4%, that would be up here. So that wouldn't give you the 73, it would give you some other value. Let's take a look at part C. And they're just talking about the probability of being rejected. So I'll just say let, in this case, A equal to being rejected from the Marines, or getting rejected. Okay, so the probability of A is equal to the following. And based on the problem, they're rejecting them if they're too short or too tall. So technically, 3% plus 4%, or 0.03 plus 0.04, this is equal to 0.07. So based on the new requirements, the Marines are actually rejecting 7% of the population. In this case, this is for actual males.